Hello everyone. With this video, I will tell you how to implement the BJT amplifier using AM Spice. The first step is to mark all the nodes. By default, ground is node 0. Remaining nodes, you can mark it as per your sequence. So I have marked it over here as per my sequence. Next, we start with the coding, and the first thing which we consider is the input voltage. We have to give input voltage of 10 millivolts peak to peak at 1 kilohertz. In AM Spice, capital V indicates that it is a voltage. So if you see the code, capital V is indicating it is a voltage. Then this notation can be taken anything as per your understanding. I have taken IN for input. The input is between node 1 and 0. So input is between node 1 and 0. It is AC in nature, therefore AC, sinusoidal, and this is the default offset value, which should be 0, and peak value. Since 10 millivolts is peak to peak value, the peak value comes at, and the frequency range 1 kilohertz. Next is implementing the DC voltage. Again, capital V indicates voltage. Then it is connected between node 2 and node 0. So between 2 and 0, 10 volts. Next, we will consider the resistor R1. Capital R indicates that it is a resistor. So capital R for resistance, notation for the first resistance we are talking about. It is between node 2 and 3 of value 47K. So between 2 and 3 of value 47K. Similarly, resistance R2 is between 3 and 0. Resistance RC is between 2 and 4. Resistance RE is between 5 and 0. Resistance RL is between 6 and 0. Next is writing the syntax for the capacitors. The capacitor is given by the notation capital C. So capital C stands for the capacitor, and if we see, capacitor 1 is connected between node 1 and 3. So connected between node 1 and 3, value is of 10 micro. In AM Spice, micro is capital U, so 10 micro. Similarly, C2 is connected between 4 and 6. CE is connected between 5 and 0. Till here, we have considered all the resistances, DC sources and capacitance. Next, we have to consider the transistor. Transistor is given by capital Q. So if you see over here, capital Q indicates that this is a transistor. The nodes are, the node for collector will come first, then node for the base, and then node for the emitter. So collector, base and emitter. 4 is the collector node, 3 is the base node, and 5 is the emitter node. And then the model of the transistor which is used. This is the model of the transistor which is in use. Next, you have to include this transistor in this model in the programming. Therefore, dot model, the name of your model, the type, it is NPN type, and then different parameters of the transistor. This completes the coding of the amplifier in AMSpice. Next will be to copy this in the AMSpice workspace. So let's copy this. In AMSpice, the first line is by default the comment line. So let's write BJT Amplifier parameters, and then is the code. Now, after copying it, we have the code with us. As I told you, the first line is by default the comment line. Now we have to do the simulation to find the voltage gain. Go to transient response analysis. Step size, we can put it as 0.1 milli. Final time is 2 milli. Save it. TR, run again. We will get this window. In this window, basically the x-axis is the time axis, and V1, V2, V3, all the node voltages are available on the y-axis. But we need to select the voltage which we want to see with respect to time. So we want to see basically the input because we want to find the voltage gain. Therefore, we will be seeing the input which is at node 1, and we will be seeing the output which is at node 6. So V1 and V6 is our area of interest. Click OK. You will get this window. In this, your red one will be V1 and green one is V6. That is, red one is the input and green is the output. Then simulate it using the symbol of simulation. Okay. You will see that we are able to see something but not in a proper format. So format auto scale. This is the output waveform. Just put the grids so we can note down the readings properly. The green one is the output and the red one is the input. With respect to the output, the input is very small because it is in 10 millivolts range. Therefore, it is not coming in the scale because it is very small as compared to the output waveform. Next step is you need to find out what is the voltage gain of the circuit. So let's copy this waveform and try to find out what is the voltage gain. So I have this as the waveform with me. Approximately the peak value over here is approximately 0.6 volts. Similarly, over here also it is approximately 0.6 volts negative. If we compare with respect to input, there is a phase shift of 180 degrees for the output. The peak to peak value of this output is nothing but 1.2 volts. Therefore, VO is equal to V6 because it is at the sixth node, V6, which is equal to 1.2 volts. AV, that is voltage gain, is equal to VO divided by BI. Divided by BI. This is equal to 1.2 divided by 10 milli. So it comes out to be approximately 120. AV is coming out to be 120. So we have seen how to find out the voltage gain for your circuit using AM Spice. Next is to find out the input impedance, another very important parameter for BJT amplifier. To find the input impedance, there is a small change in the circuit. The input voltage, instead of applying the input voltage, we will be applying the input current. So current source is connected at the input. If there is a current source, then there should be a resistance also. That means the voltage source is not there and the current source is there along with the resistance. So this V in 10 AC sign is not there in the circuit, and we have to connect the current source. Capital I stands for current source. So if you can look at this equation, capital I stands for current source, IN is for the input side. It is connected from 0 to 1. It is going from 0 to 1. So from 0 to 1, type is AC and magnitude which we are taking is 1 amperes. Similarly, with the current source, the resistance is in parallel. So RG connected between 1 and 0, 100 G. This is the coding for input impedance. So let's put it in the AM Spice and see what is the effect over there. This was for our voltage gain. Exit it. We haven't saved the circuit, so we need to save it. BJT Amplifier. For input impedance, VIN line is not coming because you're not giving it the voltage source. So instead of deleting it, we will be just putting a star. That means this is acting as a comment line now. It will not be taken as a port. And input current I in is between 0 and 1, AC in nature of 1 amperes, and a resistance Rg is also connected between 0 and 100 gauge. So this completes the coding for input impedance. To find the input impedance, we have to go to AC analysis parameter. So click on AC analysis parameter. You have linear, octave, decade. But we want to see the linear wave. Give the points as 5. Start frequency as 10 Hz and end frequency as 10 kilohertz. So AC, save, AC run. Now on the x-axis the parameter is frequency, and you can see the various node voltages at this frequency. But we want to find out input impedance, therefore we will be just focusing on VI. What is the input impedance? Click on OK. You will get this sheet. Then simulate. OK. Then auto scale. I think I have done something. I have selected frequency also. Yeah, AC, save, AC run, only V1. Okay. Okay. Format auto scale. So this is the output waveform which we are getting. Let's draw the grids. So this is your waveform for input impedance. To find the input impedance, let's copy this also. So you have got the input impedance graph. Now input impedance is found out at 1 kilohertz. We are making the circuit to operate at 1 kilohertz. So this voltage is approximately 1 kilohertz. So at 1 kilohertz, approximately how much is the voltage V1? So just extend it. It is cutting at this point over here, approximately 4.5. So V in is nothing but V1, which is equal to 4.5K. Therefore, Zi is equal to V in divided by I. We have applied a current source over here of value 1 ampere. So 4.5 K divided by 1 amperes. Therefore, the answer is 4.5 K. Zi is 4.5 K for your designed circuit. Next is the output impedance. The output impedance for any circuit is calculated at the output side when the input voltage is grounded or it is zero. So if you see, the change in the circuit is the input voltage. I have taken it to be 0 volts, and the current source is connected at the output side. So change in the coding will be input voltage VIN. Instead of 5 milli, we have made it as 0 because it is connected to ground, and your IIN over here we can write it as IIN0, I0, indicating that it is about voltage, it is about output impedance, and it is connected between, this was your node 6, so it is connected between 6 and 0, and RG is also connected between 6 and 0. So let's see what happens in the MSpice. So this which we have commented, we will uncomment it, make this as 0 milli, and this is output side IO, it will be between 6 and 0. RG is also between 6 and 0. That's it. That is the coding for output impedance. Go to AC, the points are selected, save, go to AC, run, simulated, OK, format, auto scale. Yeah, I made a mistake again. Yeah, AC, save, AC, run. Yeah. We have to select the output voltage V6 because we are finding the output impedance. OK, format, auto scale, simulation, OK, format, auto scale. We got the output waveform, x-axis, grid, format, y-axis, OK, format, y-axis, So this is the waveform for output voltage with respect to frequency. Now let's calculate the output impedance. So copy this. So let's see, your 1K is approximately over here. So at 1K the output comes out to be over here, which is approximately 3.36. Therefore VO, which is equal to V6, is equal to 3.36 K. Therefore ZO is equal to VO by IO. IO we have taken it to be 1 amperes. So this comes out to be 3.36 K. After we are done with this, we have found out 3 parameters: voltage gain, input impedance and output impedance. But we need to find out the current gain also. So there's no need to draw the graph of current gain. We have the relation of current gain is equal to AV into ZI by ZO. So we have the practical value of AV, which was approximately 120. We have the practical value of ZI. You can please look to your graph. I think its approximate value was 4.5 K and ZO is 3.36. So doing the calculations, you will get the current gain. So that's all. I hope this video will help you with the AM Spice simulation of BJT amplifier. Next video I'll upload how we will be doing it on the mobile app also. Thank you.